All right, so I'm going to give it another shot trying to explain how we can figure out what the derivative function is based off of the graph. And we want to use tangent lines and the slopes of the tangent lines to figure out what's going on. So I brought this up on Desmos, and what we're going to do is we're going to find out what the different slopes are for the tangent lines at different points, and then we're going to use that to make a table of values over here, and we're going to see how those are all going to sort out. So if you were to take a tangent line here, now it's pretty steep, and we can count it going from right here. So it's down 1, 2, 3, 4, 5, 6 over 1. So you can see it's down 6 over 1, which is why it says -6 right there. And so we could put in -6. That's our slope. And so we're just looking for our slope. And so that's that, okay? And so now I'm going to go and I'm going to make this. Now we're going to go to k equals 2. All right, so we're a little bit closer now. You can see f prime of 2 is -4. And so you can see right here, it touches right there. And so it's down 4 over 1. And so that means our slope is -4 right there. And so it's not as steep as before. So like before, we were at, you can see like as we move, the graph flattens out. It's not getting as steep. It starts flattening out. And you can see how it just curves right along and basically stays right along it, imagine, if you will. So I got my apple here, and the pen then is essentially touching it like a tangent line, and it's going to follow. And so it's right here, kind of steep, flattens out, gets flat, and then gets steeper is the idea. And so it's the same thing that's going on right here with our tangent line, that it's following right alongside, and it just is bending along. The line doesn't bend, it just follows the bend of the parabola is what's going on. And we take different points. And so now we're at 3. And we can see right here that it says f prime of 3 is -2. And again, so if we look right here, see how it touches at that corner, so it's down 2 over 1, so -2. So -2. And so it's getting flatter, which means flat means zero slope. Zero slope is flat. So we can see that we're getting closer to the 0 is the idea. We're getting closer to the 0. And so it keeps going. And the closer we get to 4, the flatter it gets. I mean, 3.9, pretty darn flat. But then at 4, it's hard to see right there, but it's right there on the x-axis. It's right on it. So so we have that right there at 4. And then we look right here, is showing that f prime of k is 4, f prime of 4 is 0. And so we have 0 right there. Then we could go and change this now. We'll go to, start getting steeper, but positive now. So now it's going up. Okay, getting steeper again, positive. And again, we see we touch right here. That's our point of tangency. And goes up 2 over 1. And so that's why our derivative is 2 at that point. So 2. And then we can go at 6. So even steeper now. And so it touches right there. That's where 6 is. And so then you can go count, and it's from here, it's up 4 over 1, or from here, it's up 4 over 1. However you want to count it, it's still the same slope. So it's still 4. Now that one happens to go like that, okay? And then we could do 7, and so we end up with, right here, f prime of 7 is 6. And you can see that it's, we know that parabolas are nice and symmetrical, which means that over here, these slopes, these were the negatives of these ones. It's nice and it's even, and it should be that way. And you can see right here, -6, -4, -2, 0, -2, 4, 6, and we get that going on. And so we get this line going through. And if we wanted to, you can see that every single time along this, and these points right here, these are where our derivatives would be. And then we could just go through, and you can look at them, you can connect the dots, and you can see it makes a straight line. And in particular, we can look at that dots and say, oh, well, every single time it goes up 2 over 1, up 2 over 1, up 2 over 1. So that's slope of 2 times x minus, and then, well, our x-intercept is 4, so x minus 4 in parentheses. And so you can see that that's our line. Now, two things to note about this. This is the derivative function. Okay, this is the derivative function. This dark one is the derivative function. I wish they would have picked a different color. I wish I knew how to change colors on this because I would prefer it to be a different color besides this that way, because it kind of looks a little bit like this one. So let's just take, let's put in this, let's go with 2x minus 8. All right, so we got the black one there. So it's the same one. I just distributed in the two. Okay, so we'll take that off. Okay, so it's the same line. But now you can see that this black line, this is the derivative line. Okay, this is the derivative function. This blue, purple, whatever you want to call it, is the tangent line. Tangent lines are different than derivative functions. It just so happens that the derivative function is linear. Not every time will that be the case. Most of the time it will not. But what we do get is that this is the same thing going on here, that we get this slope happening, okay? So that's the idea of what's going on here and how we can get those and we can plot those points. Now, personally, what I would do is, if it were me, I wouldn't freak out too much about the idea. I would just say, hey, it starts off very steep, so it's a pretty big negative number. It gets a little bit flatter. You can just hold the, so you just get the pen up there and you just see how the pen flats. It starts off steep, but with a negative slope. Okay, so remember, so we move this back. So it starts off steep with a negative slope, gets flatter, still negative slope, still negative slope, still negative slope, zero slope. But as the slope gets flatter, if the slope gets flatter, that means the slope gets smaller, gets closer to zero. And if we watch this, you can watch right here, this is the derivative. So we started off again, pretty steep, and it starts flattening out, and the derivative keeps shrinking. Okay, and it keeps getting closer to zero. So I mean, the value shrinks, not the absolute value shrinks, not the magnitude. But so it starts shrinking, and then it starts picking back up, and it gets steeper, which means that the slope gets bigger, or the derivative gets bigger, and then it keeps going like this, on and on and on and on until forever, and it just gets steeper and steeper and steeper. And so this purple one, this is your tangent line, and you have an infinite number of tangent lines to it, but there's only one derivative function that corresponds to it, like that. So we have this sort of thing going on. Now, we could do a little bit different sort of thing, and we could go with maybe a little bit more challenging one with an x cubed or something like that. So maybe we could take a look at that. Yeah, let's do one of those just for fun. All right, so let's say we have x cubed minus x. Oh, you know what? Let's make it a little bit bigger, a little bit easier to see. So x cubed minus 8x. Okay, x cubed minus 8x. All right, so we got that. Okay, so when we go through and we're taking a look at the derivatives, okay, and if we were to just use this and go say, hey, f prime of k, all right, and I'm just using k because what that does is it makes f is not a function defined, so we're going to call this f of x equals, okay, so we add a slider. And so what we could do is we could take a look at what f k is, right? And so now we're going to make a table, okay? And so, and it goes all the way from negative 10 to 10. So what the heck? Negative 10, negative 9, a lot of fills. Okay, so we'll do that. All right, and so now we're going to take a look, and so we'll go all the way back to negative 10. Oops. So we have 292. Okay, that's not showing up on the graph. All right, then we'll go 9, 235. All right, 8, 184. And so what happens is all these values over here, I mean, before this point, this, right here, whatever that happens to be, all these values over here, the slope is positive and it's very, very steep. I mean, these are slopes. This is up 292 over 1. Very steep stuff. And so, and as we keep going, we're going to see that it's flattening out. I mean, these are still very steep, but they're getting flatter is the idea. And so -6 is 100. Okay, and you can see that, it's really starting to slow down too, because, I mean, 184 to 39, that's 35, 45, and then 39, okay, and then 5, so we got 67, and then we got 4, which is going to be 40, and then 3, which is 19, two, which is 4, and then we got -1, so we have -5. So what happened here is that you can see right there at this point, our maximum point, to the left of that, to left side of this, the function is increasing. Afterwards, it's decreasing. Increasing function means positive slope. Positive slope means positive derivative. Now the function is decreasing, so it means negative slope. And you can see right here, it's pretty darn, so it's -5. And then what's going to happen is we're going to at 0, we're going to get another one. So let's just go with, equals 0. We have -8. So, and then we're going to start going up. 1. And we have -5 again. And then we're going to put in 2. And can you guess what it's going to be? 4. Are you seeing the pattern yet? Let's just do one more. 19. So -8, -5, -5, 4, 4, 19, 19, 40 to match up with that one, 67 match up with that one, 100 to match up with that one, 139 to match up with that one, 184, it's supposed to be 8. Okay. Anyways, so now we zoom out, you can see that what do these points make compared to that? And so, and that's the idea. And you can see that it gets steeper and steeper. And so this actually produces a new function altogether, which is going to be 3x squared minus 8. And it follows right, that's what it is. And so then if we come back here, back to the normal zoom, and maybe a little bit farther out, you can see right here, -1.633, -1.633. That was the max. That's where the derivative is 0, because it's flat there. 1.633, 1.633. That's the minimum, and again, 0 there. So between this point and that point, the function is decreasing, which means that the slope has to be negative, which means our derivative must be below the x-axis. To the left of this one, then this function, this red function, is increasing, which means its slope is positive, which means its derivative is positive, which means the graph of the derivative must be above the x-axis. Over here, we have this one increasing again, which means the slope is positive. If the slope is positive, the derivative is positive. If the derivative is positive, the graph of the derivative must be above the x-axis, and that's what's going on. And so you can see that with that. And so this is just a little bit different variation. So I hope that helps with the explanations.